Let's start with server load balancer or the SLB. How many of you guys work on the AWS ELB, like the application load balancer or the classic load balancer? Okay, now let's move forward. No problem, no problem. So we have the SLB concept, architecture, components, additional settings, recap and demo, and hands-on lab. Now SLB, suppose you are trying to access the server, the ECS instance. The users are increased, load are increased. So if the load are increases, definitely the multiple server will be provisioned. But the thing is, the number of users, how the number of users will connect with multiple servers without a load balancer. This is how SLB work. Like in the server load balancer, we have 3 ECS instances, and the user increases, the traffic will also increase. So the server load balancer is actually the traffic distribution service control that distribute the incoming traffic among multiple elastic compute service instances. So what's the benefit of using server load balancer? It's high availability, scalability, low cost, and security. So we have already discussed the region is the collection of zones like the data centers. If we talk about the architectures, so Alibaba Cloud offer different 2 types of SLB instance, called the CLB, called the classic load balancer, and the ALB, application load balancer. Classic load balancer architecture is simply use the Linux virtual servers with the keep alive. If we talk about the layer 7, use Tangents, a web server based on the Nginx. Is the TCP UDP traffic, HTTP HTTPS traffic, is internet, and is connected with the LVS cluster. What is LVS cluster? LVS cluster is actually the TCP or UDP options which is connected with the ECS instance and is connected with the tangent clusters as well. So these are the clusters which help you to work as a load balancers or the server load balancer in Alibaba Cloud. So Alibaba Cloud, 2 type of SLB. One is the classic load balancer, second is the application load balancers. The application load balancer architectures allow you to work on layer 7, while the ALB is based on the network base and it's allow you to work on layer 4. So these are the 2 different segments of the application load balancers. So we will start with the ALB. The good thing of ALB is supported by the QUIC, quick is the protocol which actually support the HTTP2 and the other services. So ALB is based on the NVF network called the function virtualization architecture, which allow you to scale up your own seamless like CLB. So CLB is the basic classic load balancer, you can say. ALB is the application load balancer. So please read it out and then we move forward. Okay, let's move forward. So if you want to see the difference between SLB and ALB, CLB and ALB, both are the part of SLB called the server load balancers. So if you see the scope in the CLB is the robust processing capabilities at layer 4, support TCP, UDP, HTTP, HTTPS. These are the options which you can get. In the application load balancers, we have the robust capability for layer 7. Remember, when we talk about the layer 7, it means that we are talking about the HTTP and HTTPS. Performance, the based on the tangent LVS clusters, based on the FFV platforms. You just need to read it out. You don't need to memorize, because we have a focus on the lab more towards. But remember, in order to pass the exam, the theory is very important for you. So don't miss the theory. So layer 4 CLB called the classic load balancer support both TCP and UDP, incoming client connection bound to server connection. No header modification is allowed. If we talk about the layer 7 is support HTTP and HTTPS. The connection terminated at the load balancer and the pool to the servers. Header may be modified and X forward for header contain client IP address. If we talk about the application load balancers, there is some different rules apart from the existing rules. The support routing based URL, domain and cookie content. Like आप domain का नाम डाल सकते हैं. You can add the URL parameters as well, and you can traffic splitting mirror. Traffic splitting mirror means you can split the traffic into two different servers on the basis of the traffic. नाम से और आईपी से आप ट्रैफिक को इजीली स्प्लिट कर सकते हैं. Now if we talk about the components, the SLB components, so we have different components from the SLB load balancer instance, listener or backend instance. So SLB load balancer instance are running load balancer service that receive and distributes incoming traffic to the backend servers. What is listener? The listener waits for client request and forward the request to the backend servers. It means the listener is a component which allow you to get the traffic from outside and is coming from the inside. The listener will receive the client response coming after the firewall or after the load balancers. Listener is actually exists behind the load balancer. The backend servers are those servers, these are the diagrams, where the actual traffic are coming in order to get the service. Listeners basically allow servers that which traffic is coming for which server. So that's how things work. So SLB instances the cost optimization. So public SLB is the pay as you go model, like on per hour basis, and the hour is the 750 hours a month. So it means if the component price is $1 per hour, it means you will have to pay $750 per month because the hours are 750 per month. Okay, so the SLB basically start with the public network SLB, and then it will move towards the private SLB. So first we need to take advantage of multi-tier architecture and the free private SLB instance to have the best trade-off between performance and cost. Components, the CLB listeners. So define the protocols and port on which the load balancer listens for incoming connections. Each load balancer need at least one listener to accept incoming traffic. So the forwarding rules, session stiffness, health check configurations, and the peak bandwidth are the 4 components. So what is forwarding rules? Forwarding rules are defined on listeners here, like the traffic is coming from outside to the inside. Which server get this traffic, what's the speed, the all will be defined by the listeners. Session stiffness is the components, is the options. If we enable that, we can stiffness sessions on one servers on each time. Health check configuration are done by the listener level, and the peak bandwidth can be set at the instance level. If we talk about the forwarding rules, so we have the round robin options. Requests are distributed across the group of backend ECS instance servers. Weight based round robin, you can set up a weight for each backend server. Server with the higher weights receive more requests than those with have the low weights. The third one is the weight leech connection, called the WLC. This allow you to set up the traffic on those options or those servers which we have the less load on the server. So these 3 options are available. Now what's the limitations of using CLB, classic load balancer? So here is the sum of the limitation which you need to face when you use the CLB. So the number 1 limitation is you can set up to 50 listeners to be added on a server load balancer on each site for each applications. So the up to 50 load balancers can be added on a load balance instance, and each will correspond to the specific applications. Like we have one server and we have multiple applications on each server. We can set up 50 listeners in order to correspond the right application traffic on the right server. Now let's talk about the second one. Because the IP address presented by the CLB created a single interface through backend, we have 2 server groups are supported. The number 1, master slave server group. Second is the vServer group. The master slave server group is actually when the master server works normally and its requests are distributed to it when it's down. vServer group, which is the most recommended group, is when you need to distribute different requests to different backend servers, or you want to configure domain name or URL forwarding rules versus vServer groups. So let's repeat these options. vServer group is actually need to distribute different requests to different backend servers. This is the vServer group, as you can see. or you want to configure domain name or URL forwarding, use vserver group. The master slave server group is actually when the master server works normally, request to distribute in it. When it's down, request will be distributed to the slave server. Is an active passive option in the master server group, while in the vserver group there is no active passive options available. Now let's talk about the ALB listeners, called the application load balancer. Define the protocols and ports on which the load balancer listens for incoming connections. For load balancers, need at least one listener to accept incoming traffic. Listener specify one or more matching rules which determine which backend server group will receive incoming traffic. For ALB, the listeners also specify the SSL certificate to use HTTPS listener type. Now if we talk about the ALB components, the application load balancer server group can each receive a virtual IP address and a listener associated with the ALB, which can be forward traffic to multiple backend servers. Now let me explain in my words. The backend server groups are those groups where your servers are actually exist. So if we talk about the whole server load balancer components is divided into three different parts: front end load balancers, listeners, and the backend servers. So the CLB and ALB backend instance is a set of cloud servers that you add to the server load balancer instance to process distributed requests. SLB service forward external requests to the backend servers to process according to the defined rules. Like if we define the rules here in the listeners, it can be defined and it can be forward the traffic from one listeners to this backend servers. ECS instance can be registered with the same load balancer using multiple ports, so we can load distribution load on multiple ECS instance. Now let's talk about the limitation of the backend server. We discussed the limitation of the listeners. Now the limitation of backend server, regardless you are using the ALB and CLB. So the server load balancer doesn't support cross region, remember. It will never support cross region. User must ensure that the region of the ECS instance or server load balancer instance is the same. Like we can use a multi-zone, but we cannot use a multi-region. Okay. The second option is the server load balancer doesn't limit the operating system, like you are using Linux or Windows, it doesn't matter. As long as the application deployed on the each instance on the same port, like the ports should be same. Now check this part. This is the option where the HTTP health check allow traffic to shift it away from impaired or failure instance. So as you can see, we have the health check options, and in the health check options which allow you to traffic to be shifted away from impaired or fail instance. Are you able to listen my voice clearly? Hello, are you all able to listen? Okay. some issues in voice might be there at your end, because other one is very perfectly. So अगर मेरी आवाज़ क्लियर ना आए, प्लीज़ डू लेट मी नो. ऐसा ना हो कि मैं बोलता रहूँ और आपको कुछ सुनाई ना दे. So now let's discuss here. So let's talk about the backend instances. So how backend instances will work. So in the backend instance, if the server will not respond, it will move on another server. Is health check allow for traffic to be shifted away from impair or fail instance? Like we have HTTP request head, HTTP status code. We have the sync acknowledge options, sync plus acknowledge option, request options. So this is how the SLB and the backend instance work together. Now we have another option called the UDP listeners, called the user datagram protocol listener. This is actually the classic load balancer layer 4 listeners only, where the only UDP and TCP works. Let's talk about the additional settings. So the multi-zone disaster tolerance utilize the primary and backup zone features in SLB. If the primary zone become unavailable, just like this diagram, server load balancer rapidly switch to the backup zone. This is the backup zone, right? To restore the server capabilities within 30 seconds. When the primary zone becomes available, server load balancer automatically switch back to the primary zone. Server load balancer cross region disaster tolerance. Now, as you know that the server load balancer doesn't support cross region disaster tolerance. So in that case, there is another solutions come with the SLB called the Cloud DNS. So combined with DNS, you can achieve cross-region disaster tolerance by deploying server load balancer in different regions and using DNS to resolve the domain name to IP address of the server load balancer instances. So there's an internet option, cloud DNS option, connected with the routers with the load balancers like either primary or secondary. And here is the router options available, which is connected with the master node or a slave node, and the cloud DNS connected with the options, it's connected with the slave options. Server load balancer integrate with the auto scaling to manage the scaling of the each listener independently. It's maintain ECS instance availability, which actually detect impair ECS instance. Now, if you see the diagram, let me re-explain the diagram. How many of you guys doesn't understand this diagram? किस किस को समझ में नहीं आया ये? Okay, so everyone now understand. Okay. So maintain ECS instance availability is detect impair ECS instances, replace the instance automatically. It automatically scale your ECS fleet, follow the demand curve of your application and reduce the need of the manually provision ECS capacity. Automatically bound new ECS instance to the server load balancer and run at the optimal utilization. The SLD provide protection against DDoS attack up to 5 gigabit per second. The good thing is that it support the 5 gigabit per second DDoS attack, which is free of cost. All traffic from the internet must first go through anti-DDoS basic and then arrive at a server load balancer. Anti-DDoS basic can defend against attacks such as sync flood, UDP flood, acknowledgement flood, ICMP like ping flood. Sometimes the user keep pinging, query flood, NTP reply flood, and the HTTP flood. Now the Gia asking, is the server load balancer is another region on the same SLB? No, either a primary or a secondary, both on the same region like master node and the slave node. But yes, you can set up a different SLB in different region and set up with the cloud DNS with the active passive failover. Like if the active is down, all the traffic will go towards the passive side. But within the load balancer, all the things must be on the same region. Okay. Flow cleaning when the incoming internet traffic. Now we have the security part of the SLB. If we talk about the security part, so anti-DDoS basics set the cleaning threshold and the black hole threshold according to the public network bandwidth configured for the server load balancer. Like flow cleaning when the incoming internet traffic exceed the cleaning threshold or match the certain attacks traffic models, flow cleaning is triggered, automatically triggered. You don't need to do anything. Black hole when the incoming internet traffic exceed the default traffic threshold, the black hole will be triggered. All the traffic will be discarded for the security of the cluster. Now let's talk about the recap. Fully managed, scalable and highly available load balancing platform. Content-based routing allow requests to be routed to a different application behind the single load balancer. Allow for multiple applications to be hosted behind the server load balancer, and multiple applications behind a single load balancer provide a significant cost saving. So what you need to do is set up a server load balancer behind the machine's provision on the ECS and then attach with. Provide native support for microservice and container based architecture. Now let's talk about the hands-on. So this is the hands-on advanced configuration of backend and use server load balancer to realize high availability. So let's try to complete this lab on the LabX account. Okay, let me re-enroll. Okay, now we have one attempt available. Remind me, I will do the same lab of the the ECS part as well. Now we are going to use the server load balancer to realize high availability. How it will work, the whole process are available here. Let me give you the link on the chat available. Where's the chat? You can save it. Okay, OS is this, please share SLB use case when required and when not, and other load balance, another balance. Okay, so OS there is very simple option. We use SLB for normally three different purpose number one, or use case number one, when you have more than one server on the same application and you want to create the round robin method, like the server traffic comes either one server or second server. So in order to maintain the round robin method you need to set up the load balancer. अगर आप चाहते हैं कि आपका ट्रैफिक एक से ज़्यादा सर्वर पर एक वक्त में जाए, एक यूज़र सर्वर वन पे आए, एक यूज़र सर्वर टू पर आए, देन व्हाट यू नीड टू डू इज़ आपने लोड बैलेंसर लगाना है. इज़ द यूज़ केस नंबर वन. नाउ द यूज़ केस नंबर टू, if you want to protect your server from outside attacks, so you normally set up the load balancer in front of your machine. Okay, number three, if you want to configure the WAF on the machine, then you will use that. Now let's start with the lab. Okay जी, so let's open the console. What I need to do is, this is my username, this is my password. First I need to log out this account, otherwise it will not work. Just 1 minute, guys. So once the lab is activated, we have this time, like 2 hours, to complete this lab. Don't know what's going on. Just 1 minute. Let me open in another tab. If you want, you can sign up on the LabX account as well. Now it's working fine here. There is some cache issue. No, LabX are not free, unfortunately. You will have to pay. हाँ मेरे पास आओ ज़रा. So it's taking time to open. So what we need to do is we need to go to the load balancer. Okay, now we are on the load balancer, and the next step which we need to follow is, this is the server load balancers. We need to start this and check the machines and other options. So as you can see, we have completed this pass. We have the ECS instance in the specific region. Which region? Yeah, Silicon Valley. We have 2 machines. So what we need to do is we need to check, set up the start Apache server. all the things are available. Okay, instance details, IP, connect the putty, connect the server via VNC, set up the new password of the VNC, go inside, right, and using the server install the Apache server here, right. Once the Apache is there, right, and using Apache we can finalize this part. Then go to the server load balancer in the CLB, classic load balancer. Under load balancers, set up the backend servers at both servers, right, in this one, and then set up a default server group, set up a listeners, and then as you can see, this is ECS1, this is ECS2, so both servers are available, right. We can set up the different weightage from 100 to 50, like 2 times the traffic goes on server 1, the 1 times traffic goes on server 2. So this is the complete lab, right, which we need to perform. So let me show you the complete step one by one so that you can easily understand the process. We can use the putty tool as well, or we can use the VNC passwords as well, right. This is the password for the default ECS instance. So once we go inside, what we need to do is get apt update button, apt install Apache 2, and after that Apache 2, it's active status running, and then we need to run this command, which is actually replace index.html. This line will be add, right, ECS1 and ECS2. So let's start. Are you all ready for the lab? So let me open the console, go to the server load balancer, like the classic load balancer. In the classic load balancer, we need to go to the Silicon Valley. Now we have the instance available, the SLB. In the SLB, instead of SLB, we need to go to Elastic Compute Service. Okay, now you can see we have two machines running on the ECS, Elastic Compute Service. If I go to the instance type, is the US Silicon Valley, we have two machines, and the both machines are Ubuntu Linux based machines. It's already created and the server load balancer created, but if I use this Elastic IP, which is the server 1 IP, and if I try to open here, it will not open anything. The site cannot be reached because Why is not be reachable? The reason behind that the server is empty right now. So what I need to do is I need to take access of this server like putty access, this one, get the putty access, accept, user is root, let me add the password. Now we are inside. Change settings, appearance, font, good, 16, apply. Let me a little more bold. Okay. Now we need to run the command apt get update. Copy this command. Now we are trying to install the updates in Ubuntu server. Now the updates are completed. So the next step is install the Apache server. Remember, this is server number 1. Now once it's completed, let me check this one. Oh, that's fine, that's working, but we need to do one more thing in order to complete this. Server is working now. Status, check the status in the Linux. How many of you guys are able to see my screen? Now the service is active and running. Service Apache 2 status, and then we will move towards cd var, copy that, okay. var.html, okay. Under var.html we need to put the line echo and change the index.html. Now let me check. Now, hello world, this is ECS1. ECS1 means when we test the load balancer that the traffic is coming on either server 1 and server 2, both of them, we need to change the line this way. Otherwise, if the both server open the Apache page, how will you check that the traffic is coming from either server 1 or server 2? Got my point or not? Hello everyone, are you guys available or you left? Okay, thank you. Now let's move towards this server 1 is completed. I need to do the same thing on server 2. भाई मैसेज करते रहें ताकि मुझे पता रहे कि आप तमाम लोग अवेलेबल हैं. मैं जिंदों को पढ़ा रहा हूँ, मुझे मालूम रहे. ठीक है, अगर कोई रिस्पॉन्स नहीं आएगा सो आई माइट थिंकिंग दैट आई एम द ओनली वन इन द क्लास. ओके, नाउ आई एम गोइंग टू क्लोज दिस and root and the password is okay. Now again apt get update. Second command is Apache installation. Okay, and the third thing is check the status of Apache. And the last, go to this path and under this path ECS2. Okay, things are completed now. Now I need to check the second server. ECS2, this is ECS1. Now this thing are completed. Now second option is to go to the load balancer. Under load balancer, go to the vServer group, create a vServer group, okay, let me check that's what is saying inside the lab. Does it allow me to create a vServer group or not? Okay, add backend server. Okay, backend servers, add ports, add default server group. Okay, let's start with this one. First let me go to the classic instances, add backend server first. We have a default server group, so yes, we have two servers available. Let me add both of them. Port weight 100 and the second one is 50. Add servers to add, both servers need to be add. Okay, now these two servers are added in the default server group, right? We have a vServer groups and we have a default server group. So if we go here, we set up this one, servers to add, and the default server group, the option is completed, right? Add a listener. So vServer groups is actually the target groups where the multiple vServer groups can communicate with the number of machines. So currently default server group is good for us. So add a listeners, we need to add a listeners. Front is the HTTP and the back end is also HTTP, right? So let's move forward and check that. Is a listener is available. Add listeners, HTTP, listener port 80, listener name HTTP, next. Default server groups, we have both servers port 80 available, both are port 80. So we don't have any vServers group, we are a default server group. Health check is available, and then submit. Remember the CLB is the layer 7. Now this is successful. Let me check if I miss anything in the lab. All the things are completed, layer 7s. Now it's time to run the test. So we have one IPs here. Go to the instance details where we have IP. Yeah, this is the IP of our internet facing. Let me open. Now it's the ECS1. Let me refresh. ECS1, ECS2. Now here. Now please all students must pay attention. As you can see that if I click this IP, the open is server 1. Let me refresh, is server 2. Then let me refresh server 1, server 2, server 1, server 2. It's round robin method. One traffic is coming on server 1, one traffic is going on server 2. Any questions? This is the lab how load balancer is work.